We are aware of this as we contemplate the Sun, of its enormous power and the energy it traverses across the entire solar system. It is hard to imagine anything capable of surpassing our Sun, yet beyond our own star lies a cosmic wonder that makes even the mightiest solar giants seem insignificant in comparison, VY Canis Majoris. The red supergiant defies explanation. With its irregular pulsations, huge diameter, and unpredictable behavior, the star is an enigma to scientists who are still examining its potential and power. As they investigate this magnificent star in depth, they found something frightening. Join us on this journey as we delve into the constellation Orion. Using the James Webb Telescope, we'll investigate how VY Canis Majoris evolution could change our understanding of the universe and its impact on the cosmos. If you're interested in learning more about the universe, be sure to subscribe to our channel, like this video, and turn on notifications. Despite the fact that many people are unaware of it, VY Canis Majoris can be seen in the night sky during the winter months in the northern hemisphere. Simply gaze upward, focusing on Orion and Canis Major to spot this brilliant star. It's easy to locate. The reddish-orange star marks the upper left corner of the rectangular shape of the constellation. The star is one of the largest and brightest in the night sky, making it hard to miss. However, if you have looked closely, you may have noticed that it does not remain constant. It fluctuates in brightness on occasion. This peculiarity is no coincidence. VY Canis Majoris, as the star is known, is not your typical star. Despite appearing to be just another light in the vast firmament, it is located over 640 light-years away from us. While this number may not seem impressive at first, in reality, it represents an enormous distance. To put it into perspective, even if we could travel at the speed of light, which we currently cannot, it would still take over 640 years to reach it. With today's most advanced spacecraft technology, it would take over 12 million years to make the journey, far outpacing all of human civilization's history on Earth. However, the faintness of VY Canis Majoris light is not solely due to distance. It is a red supergiant, a pulsating, ancient massive star undergoing expansion and contraction cycles. During these cycles, its brightness can either intensify or diminish, ranging over periods from tens to hundreds of days. Remarkably, VY Canis Majoris can oscillate widely in brightness, from near magnitude 0.5 to even 0 magnitude, making it incredibly striking. These changes follow cycles, the shortest being 185 days and the longest up to 2,335 days. At times, VY Canis Majoris can become very faint. For instance, in February 2021, it reportedly reached one of its lowest recorded magnitudes at plus 1.614. Although still relatively bright, this was noticeably fainter than usual. Yet, brightness is not the only remarkable trait of VY Canis Majoris. It's also renowned for its distinctive reddish hue, resulting from its relatively cool surface temperature of about 3,500 Kelvin, much lower than the Sun's surface temperature of around 5,500 Kelvin. This lower temperature means that VY Canis Majoris emits less energy per square meter than the Sun. That's why, despite being one of the largest stars known, it appears dimmer. VY Canis Majoris is like a giant content to remain low-key, not needing to flaunt its size. But don't be fooled by appearances. VY Canis Majoris is a supergiant with a mass approximately 20 times that of our Sun. This is one of the reasons why it has attracted scientific attention for centuries. It was a prominent object in the night sky even in ancient times and was first recorded by the Greek astronomer Ptolemy. Its name, derived from Arabic, means the armpit of Orion, although ancient astronomers could know little of its true nature. Modern telescopes have greatly expanded our knowledge. By examining the light emitted by VY Canis Majoris, astronomers have determined many of its characteristics, including size, temperature, and chemical composition. The Hubble Space Telescope, for instance, has provided detailed images of its surface, revealing intricate patterns of gas and dust. These observations have allowed scientists to build models to understand the star's behavior and predict its future evolution. Additionally, VY Canis Majoris has been studied using the Atacama Large Millimeter-Submillimeter Array, ALMA, a state-of-the-art observatory in Chile. ALMA has captured high-resolution images of the star's surface, revealing critical details about its structure and behavior. One of the most remarkable discoveries made with ALMA is the existence of a large plume of gas erupting from the star's surface. This plume is thought to be caused by the star's pulsations, explained by a process called convection, where hot gas rises and cold gas sinks, creating atmospheric waves that cause the star to expand and contract. Thanks to the Hubble Space Telescope, More detailed images of the star's surface have revealed complex gas and dust patterns, offering deeper insights into VY Canis Majoris behavior and helping predict its future. Moreover, VY Canis Majoris' surface is marked by dark spots, known as star spots or magnetic spots, where especially strong magnetic fields inhibit the flow of gas from the star's interior, creating cooler regions that appear darker. These star spots are thousands of times stronger than the sun's magnetic fields. The strong magnetic field causes gas on the surface to become trapped in loops or arcs, regions of intense magnetic activity that can be observed as star spots. While star spots are not unique to VY Canis Majoris, our sun also has them. Those on VY are especially fascinating due to their sheer size, several times larger than Earth and covering up to 20% of the star's surface. These colossal star spots, combined with the star's immense size and volatile behavior, suggest that VY Canis Majoris is nearing the final stages of its life. Scientists believe that it is likely to end its life in a spectacular supernova explosion, one of the most energetic events in the universe. When that happens, the explosion will be so powerful that it could outshine entire galaxies for a short time, briefly becoming one of the brightest objects visible from Earth, even during the day. Despite its distance of more than 640 light-years, the supernova would still be an awe-inspiring cosmic event, though it would not pose any direct threat to life on Earth due to its relative distance. The study of stars like VY Canis Majoris is crucial because it provides insight into the life cycles of massive stars and the dynamics of supernovae. These explosions are essential for the creation of heavier elements like iron, gold, and uranium, which are dispersed into space and eventually incorporated into new stars, planets, and even living beings. In a very real sense, the atoms in our bodies owe their existence to ancient supernovae. As astronomers continue to observe VY Canis Majoris with advanced instruments like ALMA, Hubble, and the James Webb Space Telescope, they hope to refine their models and predict more accurately when and how this majestic star might meet its end. Each new discovery not only brings us closer to understanding VY Canis Majoris itself but also adds a piece to the grand puzzle of how the universe evolves over billions of years. The mystery of this giant, fiery, flickering titan remains, and it serves as a vivid reminder of both the beauty and the transience of the cosmos. So the next time you look up at the night sky during a crisp winter evening and spot the faint reddish glow near Orion, remember, you're witnessing a cosmic powerhouse, a dying giant whose ultimate fate will one day reshape the heavens. Stay curious, keep exploring, and don't forget to subscribe for more journeys into the wonders of the universe. The surface that is significantly more expansive and greater in number than the sunspots on these star spots can have an effect on the sun. The cause and overall brightness of the star changes as the spots enter and exit. Valerica's brightness can be seen to fluctuate because the spots, being cooler, emit less light than the surrounding gas. That assists in changes in the observed brightness. In the case of Roche pulsations, the star's pulsations also play a role in the variations in brightness, as the star grows and shrinks, and as star spots move in and out of view, further amplifying the star's observed brightness. The surprising thing is that Vyrus is not as unique as one might think. While there are not many stars like it, there are some that share a number of similarities and are equally fascinating. One of Ru's cosmic cousins is Antares, a red supergiant located in the constellation Scorpius. Antares is also a variable star, meaning that its brightness changes over time, just like Biru. In addition, Antares has a mass approximately 12 times that of the Sun, with a 700 times larger radius than the Sun. So it's safe to say that Antares is no slouch in terms of size. Right now, what do you think? Consider that Vyrus already exploded and it will only take a little while before we see its presence in our skies. Inform us in the comment section if you enjoyed the video, and subscribe to the channel. Thank you so much for watching. One of the most pressing concerns regarding Vito Rho is whether it's approaching the final chapter of its stellar life. Red Vito Rho and other supergiants are massive stars nearing the end of their life cycles, and it is generally accepted that these stars explode violently as supernovae. This cataclysmic event releases an unimaginable amount of energy, briefly outshining entire galaxies. Scientists studying Vito Rho believe that it may be getting close to this devastating fate. The unusual dimming that has occurred in recent years, particularly the great dimming of late 2019 and early 2020, attracted worldwide interest from astronomers. For a time, Vito Rho became significantly dim, leading some to believe that a supernova may be imminent. However, further research showed that this dimming was not caused by a supernova precursor, but rather by a large cloud of dust ejected from the star itself. This finding, while not as dramatic, was still groundbreaking because it contributed to our understanding of how massive stars lose mass in the years leading up to their death. So if it did explode, what would that look like from Earth? Vito Rho is sufficiently far away, around 640 to 700 light-years, that its explosion would not threaten Earth in any way. Even at its brightest, the blast would be harmless to life, but it would be so obvious to the naked eye. Scientists believe if it exploded, it would become so bright that it would be visible in the daytime sky for weeks, possibly even months. At night, it would outshine the full moon. The visible aftermath of the supernova, called a supernova remnant, would remain in our skies for decades, if not centuries. A supernova in such close proximity would be a once-in-a-lifetime event, offering real-time data on stellar explosions, black hole or neutron star formation, and the creation of heavy elements in the universe. Following a red supergiant as massive as Vito Rho, what remains depends on how much its core weighs. When the core falls below a predetermined threshold, it disintegrates into a dense neutron star, an object about the size of a city but with extreme density. If it has more mass than the threshold, it may form a black hole, warping spacetime around it and swallowing anything in the vicinity. Either outcome is possible for Vito Rho, as its mass is close to the tipping point at which scientists have no idea which path it will take. That's why continued observation is so important. Numerous observatories located worldwide and in space are constantly monitoring Vito Rho. The Hubble Space Telescope captures high-resolution images of its surface and the dust sputtering around it. The Chilean ALMA array studies the gas layers ejected from the star, while the James Webb Space Telescope provides unprecedented detail in the infrared spectrum, letting astronomers see through those thick clouds of dust. Ground-based telescopes like the Very Large Telescope, VLT, also track its brightness, motion, and spectral changes. All of this data, compiled together, provides a more precise picture of the star's behavior and possible future. Whereas additional red supergiants, such as Antares or Mu Cephei, are also enormous and intriguing, Vito Rho holds a unique place in the sky. It's one of the closest and most massive stars of its kind, making it a fantastic laboratory for studying the physics of massive star formation. It is not only enormous but also wildly unstable, showing unusual variability, dust activity, and surface changes. Its sheer size is mind-boggling. When placed at the center of our solar system, it would cover everything up to Jupiter's orbit. Yet despite its grandeur, it remains a faint, flickering ember in our night sky, mysterious and powerful, but still cloaked in cosmic mystery. As scientists continue to monitor Vito Rho, they are not only trying to predict its eventual fate but also seeking to unlock the broader mysteries of stellar evolution. What we learn from this star could reshape our understanding of how massive stars live and die, how they seed the cosmos with heavy elements, and even how planetary systems might arise from the ashes of such titanic explosions. The story of Vito Rho is, in many ways, the story of the universe itself, a narrative of creation, transformation, and inevitable destruction. Every atom in our bodies, forged in the hearts of ancient stars, owes its existence to the very processes now playing out within Vito Rho. When it finally ends its life in a supernova, the spectacle will not just be an astronomical event, it will be a cosmic reminder of our own connection to the stars. Until then, we wait and watch, our telescopes trained on that flickering point of light, knowing that at any moment, we could witness one of the most awe-inspiring events in the history of human observation. The universe is vast and often silent, but in Vito Rho, we hear a star's final song, a song of immense power, quiet beauty, and the endless cycle of cosmic rebirth.